Welcome to Quadratic Formula Day 2. So you are supposed to write the quadratic formula. Don't forget that x equals, and then it is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by or all over 2a. Make sure you know how to say it as well. To solve for a quadratic equation using the quadratic formula, remember it needs to be in standard form first. So you have to subtract 5 from both sides to have 2x squared minus 3x minus 20 equals 0. And then pull out your a, your b, and your c. So a is 2, b is negative 3, and c is negative 20. Again, this one is your A, this is your B, this is your C. After that, you plug it into the quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So B is negative 3, so that goes there and there. 4a is 2, c is negative 20, and a is, again, 2. So now I'm going to come over here. So that gives me 3 plus or minus the square root of 9 plus 160, because 4 times 2 times negative 20 is a negative 160, so minus a negative, and then 2 times 2 is 4. I'm going to do I'm going to do 3 plus the square root of 169. Actually, let's just write it plus or minus, because now I'll just take that square root. So I have 3 plus the square root of 169 is the perfect 13 over 4, and 3 minus 13 over 4. So because of space, I'm going to come right up here. 16 divided by 4 is 4, and then this second one is 10 fourths or 5 halves. So these are my two values for x. Day 2 is all about problem solving. So your assignment does include just regular straightforward problems to give you more practice, but it includes the backside in specific includes problem solving, and one of them is finding the x-intercepts of the parabola. So how are the solutions to the equation related to the graph? Remember, they are the x-intercepts. So to find the x-intercepts, all you need to do are find the solutions, and that means inserting 0 for y. So the first step to finding the x-intercepts is substituting 0 in for y, because, one more time, y is 0 on the x-axis, and we're trying to find the x-intercepts where it crosses the x-axis, so when y is 0. So the first thing you do is plug 0 in for y. So negative x squared minus 2x plus 5. And then you pull out your a, your b, and your c. So a is negative 1, b is negative 2, and c is 5. Because this is in standard form, we can pull that out. If it wasn't in standard form, we'd have to put it in standard form first. So now we have x equals the opposite of b plus or minus the square root of b squared minus 4ac, ac all over 2a. Then I'm going to plug in. My b is negative 2, so that goes there. A is negative 1, and c is negative 2. So now the opposite of negative 2 is 2, plus or minus the square root. Negative 2 squared is 4, minus 4 times negative 1 times negative 2 is a negative 20. So 4 minus a negative 20 is really 4 plus 20, all over negative 2. So I'm going to come back over here. So now I have 2 plus the square root of 24 over negative 2. And I have 2 minus the square root of 24 over negative 2. Now remember, when you're putting this into the calculator, it is really, really important that you push enter after you do this top part, or use parentheses. I don't care which, but if you put it in 2 plus the square root of 24 divided by negative 2, it's going to do this division first. So do 2 plus the square root of 24, enter, divided by negative 2, and that gets you negative 3.45. And then do 2 minus the square root of 24, enter, divided by negative 2, and that gets you 1.45. And again, these are approximations because we had to approximate. We had to round. We have done some motion problems, but this, again, a lot of the applications are just being given a formula, and you need to plug the numbers in and then solve using the quadratic formula or by finding the square root. So these application problems are really no different than the ones you've done in the past, but they have this middle term. So we've already dealt with this one when an object is dropped. So there's no initial speed, there's just dropped. So now we're going to deal with this one. This is when an object is thrown either up or down. It is the height we want to end up with equals negative 16t squared, t again is in time in seconds, plus vt, v is the velocity, not the speed, but the velocity, which includes direction, t, again, time in seconds, plus the initial height where we stop. So here, a rock is thrown from a hot air balloon at 4,000 feet. So that's going to be our initial height, s. When the rock is released, its speed is 30 feet per second. So that's the velocity. But remember, the velocity includes direction. And because it is up high and it is going down, it's going in a negative direction. So it's really negative 30 feet per second. How long will it take the rock to hit the water? Remember, t is in seconds. Some of you asked that on the summative assessment. T is in seconds. So I'm going to fill in my numbers. So I'm wanting to know when it hits the ground, so when the height is 0, equals negative 16t squared, that's part of the formula, plus the velocity times t. The velocity again is 30, but because it's going down, it's negative 30t. And then my initial height is 4,000 feet. So that's the equation. And then you pull out your a, your b, and your c. So a is negative 16, b is negative 30, and c is 4,000. I would like you to pause right now and see if you can plug the numbers in and come up with the correct response with a label. All right, this is what I have so far. I plugged in my B, my A, and my C. I simplified, and then I had these two expressions, 30 plus the square root of 256,900 over negative 32, and 30 minus the square root of 256,900 divided by negative 32. And again, if I do the calculations correctly, I have to do 30 plus this square root, enter, before I do divided by, or I could use parentheses. And then I'd have to do the same thing over here, 30 minus the square root, enter, or equals to, and then divided by negative 32. Be really, really careful. So when I get this answer, the first answer, I come up with negative 6.78. And this second answer as 14.9. Because my label is seconds, it does not make sense to have a negative seconds. So that one is a false answer. So it took 14.9, approximately 14.9 seconds for the rock to hit the water 4,000 feet away if the initial velocity was 30 feet per second.